In this video, I am discussing first 15 questions. A particle loses one-third of its velocity when it strikes a block. So, before striking, its velocity is v. After traveling 4 centimeter, it loses one-third velocity, means its velocity here is 2v by 3. And further it traveled some distance x before coming to rest. What is this distance? So here, for one-dimensional motion, we use this equation. After traveling 4 centimeters, its velocity becomes 2v by 3. Substituting here, we get, since velocity decreasing, it is retarding, acceleration traveled is 4 meters. Minus 5v square by 9 is, this is one equation. Again, further it travels with this velocity, continues to its velocity decreases, finally velocity becomes 0. Again applying same formula, but here for this part it is the initial velocity 2v by 3 whole square. It is also retarding further x distance. 4v square by 9 is minus 2ax. Say this. 1 divided by 2 will give you 5 by 4 equal to 8a by 2a 4. X here is 16 by 5, 3.2. I think he given in centimeters. So he is asking in meters. 3.2 by 100 meters. That is 332 into 10 power minus 3 meters. He is asking x 30. So here what we have to find out in this problem is Cp by C. All of you know that ratio of Cp and Cv is gamma adiabatic exponent. For adiabatic process, this must be constant. But given for us is pressure is directly proportional to cube of the temperature. That means temperature has to be eliminated. Finally, I should put in this format. For ideal gas equation is this. Here P is K times T cube. In place of T, I will write PV by NR whole cube. So P here is K by NR whole cube. Sorry. K by NR whole cube. P cube V cube. That is P square V cube. Finally, this whole thing is a constant. PV power 3 by 2, C power 3 by 2, which is again constant. Gamma here is change in specific resistance. Don't misunderstood. Specific resistance and resistance are different. So resistance here is, the specific resistance is denoted with rho. Resistance changes by changing dimensions, but specific resistance, it's only depend upon nature of the material, does not change by changing dimensions. Answer is 4. But there is a possibility of confusion here. Suppose if we ask, it is not in the question, still I am explaining. If we ask how resistance changes, so wire generally of the cylindrical format. So here this is cross section. In case length is doubled, what happens? Area of cross section will be smaller, but volume will be same. So AL, which is constant. In place of area, I will write K by L. So R here is resistance changes as square of length. Suppose length is doubled, resistance will changes. New resistance is 4 times because 2L whole square is 4L square. So for this question, answer is specific resistance do not change by changing dimensions. Here it is. So from volume, only volume can be subtracted. That means dimensional formula for B is same as dimensional formula of V, which is LQ. In this problem, finally, we have to find A by B square dimensions. I got dimensions of B square dimensions will be L power 6. So pressure minus this. Pressure dimensions and A by B square dimensions must be same. Our dimension of A is same as dimension of PV square. So here pressure is force per, it is force per unit area, volume is this. So ml square, so in fact here L cube into L cube, this because V square is there, ml power 5 it is m L power 5 t power minus 2. Now to get dimensional formula of A by B square, so A dimensional formula ml power 5 t power minus 2, which is ml power minus 1 t power minus 2, which is same as pressure. Pressure is force per unit area, ml t power minus 2 by L square. So dimensional formula of pressure is this, first option correct. The work function here given it as 6.3 electron volt. Then find the threshold frequency. So this is nothing but h nu, 6.63 electron volts. What he is asking is gamma value. 1 electron volt, 1.6 into 10 power minus 19 volts. And Planck's constant 6.63 into 10 power minus 30. So here by h, which is 6.63 into by 6.63 into 10 power minus 34 to get cancel out. So which is 1.6 into 10 power 15 Hz, frequency unit is Hz. Here, vernier calipers with positive zero error shows reading loss. So in vernier calipers, no zero here, zero error, positive zero, here, negative zero error. Three cases. In case this is main scale zero, coincide with vernier zero. It is main scale zero. It is vernier scale zero. So here, no zero error at zero. In case here main scale zero, vernier scale zero is ahead of main scale zero, we say positive zero. In this case, we get value because we measured from here. So value will be definitely more than the true measurement. So statement 1 is obviously correct. So this defect, obviously manufacturing of measuring instruments. So both the statements are true. Statement 1 is true, also statement true, also true. Here a stone is released from some height and that covers 80 meters in 2 seconds from A to B. Find the distance from topmost point, let us say C to A, he is asking distance. It is dropped from this initially its velocity. After traveling this distance x, it attains velocity. With this velocity, it reaches B. AB is equal to, since it is one-dimensional motion, at A velocity, time taken to reach B is 2 seconds. Freely falling, A is G, which is time is 4 seconds. Distance he given 80. 2V plus 20. 2V here is 60. V is 30 meter per second. He is asking this distance again. Let us say it is CA. CA distance is X, which can be calculated by using same formula. We calculated here 30 square. Initially dropped one. Freely falling, we'll write from here X is 900 by 2 into this. So it is 45 meters from A. Here, energy, its kinetic energy associated with the one molecule for 1 degree of freedom is half kT. Right. Now it is per mole. Per mole means energy associated is this. This is for 1 degree of freedom. Oxygen is diatomic. So number of degrees of freedom equal to 5. So energy associated with oxygen is 5 by 2 R T. He given R value as 25 by 3. Temperature we should convert in terms of Kelvin. So here it is 125 by 2, 300 by 3, which is 100. 62.5, 6,250 joules. So here work done by electrostatic force on an object moved on a equipotential surface. An equipotential surface means suppose you take a point charge. So potential at this point due to this charge will be how much? At a distance kq by r. Even if you consider at r distance, potential is this. Even at this point, So this is a here for point charge. This only for example. For point charge, equipotential surface is sphere. At r units distance in any direction in the space, potentially same. Such points locus will be sphere. Now, work done is nothing but potential Q into from VA to VB. For example, this is A, this is B. At VA and at VB, potential is 0. Sorry, potentials are same. Difference will be 0. So work done by electrostatic force is 0 in moving object over an equipotential surface. This statement 1 is true, or assertion is true. Now, this electric field lines falls perpendicular to. That is also here. Electric field direction is this. And here, displacement will be this direction. So work done, since they are normal perpendicular, work done by electric field is E dot ds is nothing but how much? So F dot ds, which is right Q E dot ds, they are perpendicular, dot product is 0. So A and R are true and R is the correct explanation. A ring and a solid sphere of same mass and radius slide down along an inclined plane. One is ring, other is solid sphere. Find the ratio of their kinetic energies when they reach its bottom. What is the energy here? It has only potential energy, mg. It also has potential energy, but both are released from same height. But he said same mass, so its potential energy is same. Since total energy is conserved, so at A, mgh, at B, it has totally converted to this. So now, so both bodies reaches bottom and energy, kinetic energy obviously same because their potential energy, initial potential energies are same. height same, mass same, potential energy same. So their kinetic energy ratios. Say this is Ke1 by Ke2. Obviously mgh by mgh. So the ratios obviously 1:2. In LCR circuit, find the power factor. So first of all, power factor formula. What is it? R by Z. Z is what impedance? How do you find for LCR circuit? R square plus XL minus XC whole square. What is XL? Omega L. What is omega? 2 pi F. L is inductance. 2 pi F is 50 H. L is 100 pi millihenries. So it is 100 into 100, 10 ohms. XC will be 1 by omega C. Omega is 2 pi, F is 50, C is 10 power minus 3. 1000 by 100 pi. It is by pi also there. They get cancelled out. So which is again 10. So now Z becomes R square plus, since XL and XC are same, it is 0. So Z by, which implies R by Z is 1. So power factor is 1. A ball is suspended by a thread right, swings in a vertical plane so that its acceleration in the extreme position uh, and the lowest position are equal. Okay. Its acceleration in extreme position. This is lower position. It is extreme position. So what are the forces acting mg? Here is theta. Here it is g cos theta. It is g sin theta. Now at E, centripetal acceleration is equal to, since here this is a circular path, centripetal acceleration is v square by L. That is 0 at this point. Tangential acceleration, which is g sin theta. So net acceleration at E is, why it is 0? At extreme point, velocity is 0. So at L, what is the acceleration? What he told, its acceleration in the extreme position and lowest position are equal. At L, what is the acceleration it has? Mg. Only force acting on it. And it has velocity also. So acceleration is v square by L, centripetal acceleration. So what he given is v square by L is g sin theta. So v square is, and energy at L is half mv square. Energy at E is equal to mgh. So this is L. It is L cos theta. H will be L minus L cos theta. So half mv square mgl into 1 minus cos theta. So here v square is gl sin theta, which is mgl into 1 minus cos theta. mgl get cancelled. Sin theta is 2 minus cos theta. 2 sin theta by 2 cos theta by 2 is 2 into 1 minus cos theta, 2 sin square theta by 2. So tan theta by 2 is half. Theta by 2 is tan inverse half. Theta will be 2 tan inverse half. Here there exists uniform electric field. So the magnitude of electric field will be 20I, which is 20. So dipole is making an angle 30 degrees with the electric field. Then the torque will be, magnitude of the torque will be, P is what here? Dipole moment. P here is, in fact, P is sin theta, it is P bar cross A bar torque. So moment he given it as 15, electric field is 20, and it makes an angle 30 degrees. Sin 30 is half. So we get here 150 Newton meter. A particle moves 80 meters in the last 2 seconds of free fall from a height, then find the height. Last 2 seconds. Suppose it reaches ground in t seconds, in t minus 2 seconds. Distance traveled in t seconds minus distance traveled in t minus 2 seconds, c given 80 meters. G by 2 into t square minus whole square is 8. 5, G is 10. T minus 2 plus 2, which is 8. So 2t minus 2 here is 80 by 5. So 2t here is t plus t minus 2, 16 by 2. Right. So t here is 9 seconds. So height will be half gt squared. G is 10. T here is 81 into 5. 405 meters. Here it is. All of you know formula related to primary coil and secondary coil of a transformer. So this one is connected to 230 volts, 50 Hz. So number of turns in primary coil and number of turns in secondary coil, NP by NS, which is VP by VS. So here primary to secondary coil 10:1, and voltage in the primary coil is 230. VS here is 23 volts. So here resistances are which he given 46 ohms. Power in the secondary coil here, secondary coil is V square by R. In secondary coil is output is 23 volts. Resistance given 23 into 23 by 46. 11.5 watts.